Hello everyone, it's Mr. Cablin here again. I'm here to deliver the next lesson here for chapter 9. And what we're going to be doing today, we're going to be looking at two shapes. However, we're only going to look at one calculation, which is dealing with volume. And today we'll be looking at the volume of cones and spheres here. So before we begin, again, always refer back to the formula sheet over here. So we will be specifically looking at the two shapes on the right side here. As you can see, the sphere is the second shape that you see on the list there, and the cone, which is right below it. And we're only going to be looking at the volume here. Okay, so again, just make sure you have that handy when we take a look at these examples. All right. Now, when we're looking at the volume of cones and spheres, what we just want to understand again is the different parts of the formula. And for one of the shapes here, we're just going to just derive where the formula came from, because in one of these shapes, you've actually seen part of the formula for it. So I just want to briefly go over that as well. All right. So when it comes to the cones and spheres, again, these are very, very familiar shapes for you. In fact, the final example for today's lesson is very, very familiar. All right, so again, when it comes to a sphere, okay, and you're probably looking, well, that looks like a basketball. Well, you're absolutely right, because guess what? Okay, basketball is a perfect example of a sphere there. So again, what sphere is, again, it's a three-dimensional ball-shaped object. Okay, and please don't confuse this with a circle, because a circle is flat. It's in two dimensions here. So when we're talking about spheres, again, there is a circle involved, as you're going to see in the formula here. However, when it comes to a sphere, again, it's three-dimensional. Okay, so that's why when we're describing it, we're talking about any shape that's shaped like a ball. Okay, and again, what you have to see here with regards to the circular part. Okay, notice there is a radius. Okay, and the formula for that is defined by volume is equal to 4 pi r cubed over 3. Now notice that the r here is raised to the exponent 3 and not 2. Okay, so just make sure you do that. Remember that when you're doing the calculation. So when you on your calculator, you should have an x cubed key. If not, then once you take the r, okay, you can just raise the that number to the exponent 3 by pressing the exponent key and 3. All right. Okay, so that's the radius. Now, just like we did when we were dealing with the cylinder, okay, the total distance across, remember, was the diameter. Okay, so there's actually a formula for that for the sphere as well. It's not quite often used, but it is available for us here, which is going to be pi d cubed over 6. Now, what we're going to see in today's lesson is that depending on what information is given to you, okay, you can choose either with one of those formulas to solve for the volume of a sphere. All right. Now, when it comes to a cone, okay, what you have there again are three measurements there. You have the slant height, okay, you have the vertical height, which is the dotted line that you see there, and radius. Now, what you need to know about the volume of a cone, it's going to be basically the same thing as the volume of the cylinder. The only difference is that you take the volume of the cylinder and you divide it by 3. So remember that back when we were dealing with the volume of a cylinder, okay, the volume of a cylinder is the top part. Okay, so pi r squared h, okay, is the formula for the volume of a cylinder, and all a cone is a third of the volume of a cylinder. Okay, so that's just another way to understand what the formula for the volume of a cone is. Okay, now in both cases, for both spheres and cones, the units are always going to be expressed as cubic units. Okay, so when you have the measurement, okay, all the volume is that measurement raised to the exponent 3. All right. Okay, so let's take a look at some examples, and we'll start off with a nice and easy one dealing with the sphere. Okay, so what we just want to understand here with these two objects is what is given to us in terms of the measurement. Now, as you can see here, we have two choices. We have radius or diameter. So for part A over here, what you have here for the diagram, the 4 meters, okay, notice that it's the distance from the center of the circular part, okay, to the edge of it. So since we're given the radius, we're going to use the radius formula for us to solve for that question there, all right? And when you put the numbers in carefully over here, okay, remember you have to take the 4 and then cube it. Okay, you should get 268.08 cubic meters. Now, if you have a scientific calculator where you can put that all in order, you should be able to get that. Otherwise, just do the top part first, okay, and then solve for that, and then take all of that and divide it by 3. Again, everybody has different ways to solve for it, but again, with the most scientific calculators, you should be able to get it from the steps that you see there. All right. Now for part B, the only difference of part B is that the 10 feet, as you can see, is the total distance across the circular part of the sphere. So in this case over here, what we would have here would be the diameter. So we're going to use the diameter formula for that. Okay, and same thing applies here. You take the 10 and then you cube it. Okay, put all of that in your calculator and you should get approximately 523.6 cubic feet. All right. So again, it's pretty straightforward in terms of how to solve for the volume of the sphere. Just determine whether something is a radius or a diameter. All right, so the next thing we're going to do here, we're going to take a look at a volume for a cone. Again, it's something else that's straightforward. Okay, so in this case here, we have a radius here of 5, okay, and the height here of 12 millimeters. Now, the height here, again, is referring to the dotted lines going from the top of the cone, okay, to the center of the circular face here. And when you put the numbers in, again, since this is volume, you should get approximately 314.16 cubic millimeters. All right. All right, so we've looked at just two basic calculations with the volume of a cone and the volume of a sphere. So the last problem, we're going to put it all together here, and how appropriate that the shapes that we're dealing with when we're dealing with both a cone and a sphere. You guessed it, an ice cream and its cone. Okay, and what it says here, an ice cream cone is made up in the shape of a cone. Okay, and the scoop of that ice cream is approximately in the shape of a sphere. Okay, and what we want to do here, it tells us here the radius of the scoop of ice cream is 4 centimeters and the radius of the cone is 3 centimeters. And what we have to figure out here is what would be the height of the cone. And basically what we're going to do here again is we need to figure out a way to solve for this, understanding that we're solving for the height of the cone. So for based on the two formulas, the volume of the sphere and the volume of cone, what do we need to approach here first? Well, if you think about this logically, okay, think of an ice cream cone and the ice cream part. The cone has to be able to hold up the ice cream in the event that the ice cream itself melts, and so it goes inside the cone. Okay, so we have to factor that in. That's basically how we're gonna approach it. So the first thing we're gonna do here, we need to find the volume of the actual ice cream scoop here. Okay, using the formula for the volume of the sphere. Okay, and the way we do that, it tells us here that the radius of the scoop of ice cream here is 4 centimeters. So we're gonna replace that in for the R. Okay, and when we put those numbers in, okay, you're going to see that when we simplify this, the volume of the scoop of ice cream is going to be approximately 268.0826 cubic centimeters. Now, I expressed it to 4 decimal places here because we're not done the question yet, and we want the answer to be as accurate as possible here. Now, it's the next step here that's going to be a little bit confusing at first, okay, but I want you to see exactly what we're going to do with the volume of the scoop, okay, and how in the world we're going to use that to solve for the height of the cone. So for step number 2 here, we're going to take the volume of the cone, okay, and what we're going to do with the volume of the scoop is to replace it in for the volume of the cone, okay, because remember, as I mentioned before, the scoop of the ice cream, when it melts, needs to fit in the cone so it doesn't overflow, okay. Now, the radius of the cone, as you can see, is going to be 3 centimeters, so let's put the numbers in accordingly, okay, and what we have here, we have the volume, that is going to go in for the V, okay, and from there, we're going to solve for the height, just using some simple math here. All right, so let's do that, and all I'm going to do in the next step here is to put and replace the numbers in for the variables as accordingly. Now I know everybody wants to see numbers here, so I'm going to approach it that way. So the next thing I want to do here is I'm going to take the 3 squared and just simplify that, and that 3 squared will give me 9. Okay, and the next step over here, I want you to see what I'm going to do on the right side here, because like I said, most people like to see numbers, so I'll try to keep it simple here. What I'm going to do here is I'm going to take the 9 pi, and I'm going to simplify that. So if you punch in 9 pi in your calculator, okay, it's going to give you some long number, okay, but when you're writing it in the next step over here, okay, notice that what I've written here is just 28.27, okay, just keep it nice and simple here, all right? Now, in the next step here, what I'm also going to do, I'm going to take the 28.27 and then divide that by 3. And that's going to give me another decimal here of 9.42. All right, now the reason why we're using numbers, as you can see in the final step to isolate h, all we need to do now in our final step here is to divide both sides here by 9.42. Okay, and that will give us a height of the cone to be approximately 28.5 centimeters. All right, so again, when you're reading this kind of question over here, okay, just make sure you see what information is provided for you and what shapes are involved here. And once you figure all that out, you just have to think of a plan to solve the problem based on what the question is asking us to solve for here. All right. Now that wraps up all the shapes that we're going to go through step by step here. So in the next lesson here, what you're going to see are a bunch of word problems where we're actually going to put all the shapes together and determine, first of all, what shapes we have, what information is given, and what formula we're going to choose. That's why it's very important that for the next lesson that you have your formula sheet handy, because it'll make things a lot easier in terms of the flow of how we're going to solve the problems here. So until the next lesson, I'll see you then.